Hello, my name is Cyril Cabarin. I'm CEO and founder of Shark Robotics, which the mission is saving lives through technology. I'm a former military operative, and I found this company in 2016 with the ambition and the mission to saving lives through the technology. So currently we meet safety needs and for two main challenges that we fight against global warming fire, and of course we met the challenge of fire with battery fire currently for example with lithium-ion battery in the car or in the micro mobility, especially on indoor environment. So at Shark Robotics, we design and develop state-of-the-art robots. We are specialized, of course, on fire safety, but also on law enforcement and EOD for demining operations sectors. So we delivered more than 300 robots in 16 different countries. We have more than 30 patents filed and delivered. And of course, we structure the company because now we are ISO 9001, and now we are currently 70 people. And the main benefits of the not only Shark Robotics but on the robots, I mean, especially on the fire safety, is first saving lives, saving companies, saving resources. I will explain why after. And of course, it's economical solution compared to traditional solutions on the fire safety. We have a global presence in 16 different countries, mainly in European countries and in Southeast Asia, but also in Latin America. And we deliver mainly business to government agency with fire units, and also industrial company who have in their own facilities fire safety units who are able to remotely control the robots before the firefighters come after 15-20 minutes usually. So we're mastering at Shark Robotics the 4Ks of the robotics. It's the engineering, so we design the hardware solutions of our robots, okay? We integrate and we work on the softwares and also on AI, artificial intelligence bricks that we embedded and integrate inside the robot. For example, the follow me, the navigation, autonomous navigation, and also the capacity, for example, for the robot to detect the hotspots. So, for example, a flame, a fire, a high temperature. And the idea is to product and give is to give, an important, intelligence and information about the environment to support and help the firefighters on the fields to manage maybe better with more benefits and more efficiency their missions. So we design and develop also batteries with a special patent about vibration and to resist to high temperature. And of course, we make all the assembled directly in the same facilities. So, like I said, we are 70 people. We are based in France, in La Rochelle, with the headquarters, with 2,000 square meters of facilities to produce the robots. We have also a commercial office in Singapore, and we have a scientific committee to support us to define the R&D roadmap 2, 3, 5 years, and to define what will be the use case of the robotics, especially on the fire safety. So our main and our most famous robot is the Colossus robot. So it's a 500 kilogram robotics platform and designed like a Lego, for example. It's a complete system with 12 modules, and the firefighters will change the modules in 30 seconds without any tools, with their gloves during the operation. And the idea is to bring the machine that will support the man and the woman on the field directly. So, for example, the robot was engaged in Notre Dame Cathedral fire in 2019, and he was in operation during 10 hours at 900 degrees. Okay, so currently it's the world leader in firefighting robot is the Colossus, and it's a multi-purpose robot. So when we look at the modules, for example, we have several modules, like I said, for multiple missions. So the idea is to bring efficiency to the firefighter to say, with one robot, you will run several operations, several missions. You can, of course, extend the fire, make ISR for intelligence, surveillance, reconnaissance mission, especially to find, for example, the flame, the hotspot. And also you can extract wounded person, you can carry equipments. The main idea of the robotic solution on fire safety is, for example, when you have a warehouse fire, it's a very common fire. We make approximately 10 real fire with our robots deploying over the world every week. And if you look at, for example, a warehouse fire, usually the risk for the fireman is the roof that will collapse after approximately 15 minutes. So the firefighters can engage any firefighter inside the building because you have a risk of the collapsing of the roof. So the idea is to bring the robot that we go inside quickly, even if you have high temperature, smoke, etc., and will localize and find the hotspot very fast, okay, a quick, and make a surgical strike. So you give efficiency, you protect the men and the women outside the building, for example, and also your consumption of water is very reduced, approximately by 10, because usually when you don't have robots, the firefighter, for example, put fire truck around the building and throw water during several hours. So also, of course, for the insurance company, it's more interesting to save about the loss ratio because you will protect the work machine, you will protect, of course, all the goods and the assets inside the building. That's why the idea is to bring a robot that will go inside quickly, make a surgical strike, and protect the men and the women outside the building. And also, the idea is to provide intelligence and information about what happened inside the building. What is the information? What is the localization? So you can record the operation also for the insurance company and also for the firefighter who was outside the building. So we have also the little brother, which is the Reno Protect 200 kilogram robots. So more, it was designed for, we call that industrial operation fire, and also for example on the small warehouse, on the tunnel, on a car parking, when you have with a very good mobility of the robots. This robot have the same modularities than the Colossus, and of course the budget is more limited because you have less power and less hydraulic capacity compared to the Colossus robots. All our robots are remotely controlled with a tablet, of course. And the main, when we started the company, one main issue was to provide something, a robot that was very easy to use. So, for example, the training for the firefighter is just 2 hours. So you keep the tablet, you will run easily, and we provide intuitive solutions because we don't want that, for example, a firefighter become a robotician. I mean, the firefighters need to be focused on their own mission, and the robotic solution is just to assist and to bring him efficiency on the ground. So the main idea was to provide something very intuitive, very easy to use. And also we start now to integrate artificial intelligence bricks like the follow me. For example, the robot will follow the firefighters at 5 meters behind him, for example. Also, the robot will help the firefighters to find, for example, the hotspot, the flames, to detect or localize a man or a wounded person when you have smoke. So this kind of artificial intelligence tools are there to support the firefighters to give more efficiency for underground and operations. So we also following sustainable development goals, of course, because as we stated, we saving lives. We develop artificial intelligence, but for good, for the common good. And as example, we are AI for Good ambassador at the United Nations. As you look at on the pictures, it was in Geneva at the ONU in United Nations in Geneva, and we are engaged, of course, for the inclusion and diversity of provisions. Thank you very much for this quick presentation. And if you have any question, I'm here to answer. Thank you very much.
So welcome everybody to our next session at Firefighting Live. I'm joined here by Cyril Kabara of Shark Robotics, who has just delivered a great presentation on the use of robotics in firefighting tactics. So Cyril, thank you so much for joining us here today. I really appreciate your time. Just to start, could you give us a brief insight into the history and heritage of Shark Robotics?
Yes, of course. First, I was, like I said, during my experience, I was 9 years in the army as in the intelligence, and I have the opportunity to be deployed several times around the world, and to be, on the battlefield with several robots who was developed by brilliant laboratories, for example, and with a lot of AI bricks inside, but the problem and the issues on the past was when you deploy these kind of robots on the battlefield with harsh conditions, like a soldier would be, with the mud, the rain, etc. And usually, for example, the robots lose a wheel, lose the tracks after 2 hours, and it was a burden to carry on the mission. So the main idea when I quit the army, I graduated with an MBA in competitive intelligence, and the idea when I found this company was to say, okay, we need to put around the table some guy, so especially, for example, firefighters who are on the battlefield, who know exactly what is the needs and what is, for example, the capacity that would have the robots in order to, to provide support on the field directly. So we managed to find around the table some engineers and firefighters, and the idea was very simple, was we have 6 months to deploy robots. So we put money on the table, of course, and we make partnership with the Paris Fire Brigade. So they provide us their return of experience, and we gather information with the engineers, and we develop step by step a robot, a perfect robot that would be, for example, the best machine on the field to support them on the heavy operations. And we start like that. And for 6 months, we developed the first Colossus robot in 2017. And the Paris Fire Brigade, bought the first one, the one who was engaged in Notre Dame 2 years after, for example. And then, for example, now they have several robots, and we deployed over 300 robots or in 16 different countries.
Wow. So very inspiring background, actually. And also, you say it's a privilege to obviously be in the nitty gritty and next to these robots, whether it's in the military or whether it's in firefighting, and there is something incredibly fascinating about robotics. Even at a trade show, when you're walking the aisles and there's a robot kind of going down the streets doing its little things, so it's always been something that's very fascinating. And it's great to see that you're not just innovating for the sake of innovating, you're answering the demands and the challenges of firefighters in that environment, and you're meeting those needs. So that's something that's always so important when new products and machinery and technology are coming onto market. So what are the biggest challenges with the introduction of robotics into firefighting? Firefighting is an industry that can be slow to change, because obviously it's dealing with life and death, in these scenarios. So surely there must have been some challenges with this introduction.
Of course. The first challenges was, of course, to start not from the laboratory, but from the use case. And it's very important because that's different between a robot that will have a real purpose on the mission and the other one. For example, we saw you have so many robots who are very agile on the carpets, on the exhibition, like you said. For example, when you put there on harsh condition, it could be very different. So the main idea was not to start from what would be the best robot, but what is the use case, what they need on the field, and then you start to write what would be the specification of this kind of robot, and you start with them. The second challenge is, like you say, was the psychological barrier to say, to provide a robot to firefighters. And the first reaction, for example, in 2016 was, hey guys, is this robot will take my job at first? So the idea was to say, okay, no, don't worry. It's just the tools at your benefits. It will be your brother, your little brother on the ground, and it will help you, support you on the field. And put them around the table with engineers was the idea to say, okay, you will help us to develop and design the best robots in order to have the best tools when you will be in harsh condition on the ground. And in that case, they help us to move away this kind of psychological barrier. And when we came on the market to provide and to sell the robot and to introduce the robot to other, for example, fire units. Of course, the fact what we develop it with, for example, one of the main famous units on the world, which is the Paris Fire Brigade, and they are well famous, like the New York Fire Brigade, for example. It helps us, of course, to provide, to say, okay, we don't design this robot, we didn't design this robot by himself. No, we design it with firefighters who are every day on the ground and know perfectly what is the job. This was very important. And the third challenge, Rebecca, was also, and it was a request, very specific request at the beginning, was, okay, firefighters need to be focused on the missions. So they don't need to work so much or find so much to use the robot because it will be so complicated. So it was a major, critical, important on the specification that the robot will be used easily. It means to change the modules very easily with any tools, but also to operate the robots. That's why we design and develop something on the tablet and the softwares and the command control to have something with human machine interference, what will be the best, the more easy way to use it.
Mm. Yep. And you mentioned just before that obviously you're now situated in 16 different countries. Has the reception been different? You said, when you first started, it was, will this take my job? Has the reception from firefighters internationally in different countries differed depending on whether they're, structural or focusing on wildfires or urban, rural, for example? Are there different needs?
Yes, it's a very good question because depending where you are in the world, the use case and could be different and the needs could be different. So, for example, for us, we develop a robot for indoor operations. It means, for example, warehouse fire, underground car parking fire. But for wildfire, we don't find yet the benefits of a robotic solutions that you need to deploy. Because, for example, when you look at our products, one of the specification and what the needs, for example, for the Paris Fire Brigade, and we will make a demonstration in New York at the end of the month, is how I can manage to bring my robots for firefighters from a point A in a point B with several kilometers in overcrowded city with a lot of traffic. So you need to have a minimum logistic footprint, and that's the idea. So, for example, the ability to the robots to cross the door, it means it will be very size limits, very short. So you can you can embed it, you can integrate it in a simple van or, for example, even an SUV, to deploy it very fast on the ground. So depending where you are, the needs could change, and the psychological barrier is kind of different. And for example, when you look at on the US market, they have, historically they have for example, often they are more aggressive on the use case. So, for example, the firefighter need to go inside. What happened? And no matter what, they go inside. And in this kind of operation, the idea was to tell them, okay, of course, you have to go inside and you will go there. But first, send a robot just to see if everybody is okay. Find the opportunity, find information, to have information, and just to be sure that you will not have the roof on the head for your ground and for your people. So it changed, of course, the use case and how you manage the operation. And when you look at, for example, the 9/11, okay, most of the firefighters who were there and breathed some, bad things on the air, had cancer at the after. So the idea is not just on the operation, but also for after. It's better maybe if you have 1,000 meters away from this kind of bad things in the air, and will be and you protect your men. And as myself, I was deployed on the battlefield. And of course, you're here to take dangers and to make missions, which sometimes it's really dangerous. But if you can have a robot that will help you to bring back at home, it's better sometimes. Yeah, of course.
Definitely. And I think that's actually a really important point that you don't think about necessarily. It doesn't come to the forefront when you think about a new firefighting bit of equipment like this. Something that's a huge topic is obviously reducing carcinogens and and the well-being of firefighters, not just in the field, like you said, not just in a burning building, but also, for their entire lifetime. And if we can produce technologies that can help combat that, fantastic. But it is kind of changing that mindset as well, like you said, and having it be an aid as opposed to a replacement, or changing completely what the role is of a firefighter. But no, it's definitely something that is incredibly important. So thank you for raising that as well. And just on that topic as well, obviously, when it comes to new toxins and challenges that are in the air, obviously you mentioned 9/11, but one of the biggest things that happen at the moment is with electric vehicle fires. The amount of toxins that are released in that, especially in a car park setting, like you said, robot is perfect for a car park where firefighters cannot physically be there for long periods of time because of the toxins in the air. And yet, with that nature of that type of fire, with its propagation, there's a lot of challenges there. So robotics seem like quite a good solution for a lot of those challenges. I don't know if you have a viewpoint or a comment on that.
Of course, you're completely right. One of the more important use cases, of course, we have more and more important volume and number of EV cars on the town. So it's a real problem and a real issue, especially for underground car parking, because when you start a fire with an EV car, it's a completely different, because after a certain time, and we are manufacturer of batteries because we manufacture batteries for the own robot with several patents. And we know that if you have a point of non-return, that the thermal runaway. So you need to stop the thermal runaway, otherwise it's lost, and you need to remove back the car from the car parking. So that's why we developed this kind of solution on the Colossus, which is an option to lift the car, and even it's in fire, to remove out the car parking, because you have a risk, of course, to collapse all the car parking if you leave an EV car parking burning inside the car parking. Sorry. So that's very important. And this use case will be more and more common. And even in warehouse, for example, you take a warehouse, a logistic warehouse, where you have a simple toys with, lithium-ion batteries or micro mobility. It starts fire every fast. So the main idea is to use the robotic to give efficiency, of course, to make a surgical strike, but the more as quick as possible, directly on the point. And that's why unfortunately, this kind of issue will be more and more common by the time, because of the using of the EV and the lithium-ion batteries on the automotive, of course, but also on the micro-mobility, on the logistic warehouse, on the toys, everywhere.
Definitely. And do you think that in the future, new kind of attachments, obviously there's a lot of talk at the moment when in the topic of lithium-ion batteries, of using like water mist, for example, or different types of wetting agents to specifically put out the cells in a battery. Do you think that these types of, whether it's a nozzle or a monitor, for example, can be applied onto the Colossus?
Yes, we work on this kind of new tools to bring different, of course, facilities, equipment on the Colossus, but especially on the lithium-ion batteries, we see that even if you put the lithium-ion batteries on the water, they provide oxygen. So the own batteries provide the oxygen and burn even underwater. So at this moment, we didn't find any technology which is able to extend a battery if you pass the thermal runaway. So the idea is to be before 1 minute or less than 1 minute on the battery, to compact the fire, and just take care that you don't, the temperature will not raise, and you go on the thermal runaway. And in that way, you can extract the batteries and you can remove the car parking, you get the car from the car parking. But it's very complicated, honestly, very complicated.
And also, you spoke about the Notre Dame case study, and 10 hours at 900 degrees, I think is what you said, and that's a staggering stat. Does this cause any damage to the robot itself, after such an incident?
Nope, he's still on the game. I mean, the robot is still there. Yeah, he's still working with the Paris Fire Brigade. This is the first robot they have, and they are still using it. And maybe they will put him at the museum after that. But at this moment, he's still on the ground on the fire. Yeah, wow. On the battle.
And just lastly, obviously, you also spoke briefly about the introduction of artificial intelligence. and AI seems to be creeping into every single industry, whether it's professional, personal, and that's, a lot of it is thanks to generative AI and the gaining popularity in that. But in terms of the application of AI within robotics, could you expand a little bit more into these capabilities? Like, are there any concerns around this integration, for example?
I mean, the idea was to go step by step. As I said, the main psychological barrier for an operator is, okay, is this robot will take my job? I mean, it's the more common risk and fear that they have. Okay, so we go step by step, and we start with, for example, the follow me mode, which is the very common module AI brings. So the robot will follow the operators, okay, just behind. And we started to integrate, for example, the go back to position. So you go with the robot on the position B, and it will go back to the position A by himself. So these kind of tools are very simple to use and very intuitive, and you go step by step. You can have, for example, to locate the hotspot. So it's just an algorithm that will find and locate before the firefighter, or to help him to find, for example, electrical fire, who are very hard to detect because it's very, very small and very easy. Or also, of course, to have some warning if you have a CBRN threat, or you have something, especially on the gas. The robot is here to detect and to be, the eyes and the ears of the firefighters and to protect him. So the idea, once you have capabilities and AI bricks to find, autonomous decision for simple things. Okay. For me personally, I don't think that one day it will be very hard to have a fully autonomous robot that could be deployed everywhere with firefighter, because, okay, it's easy to place a robot, for example, on the same place with forward, and to say, okay, you know your place and you do your job here. Yes, it's easy. We know how to do it. It's easy. But it's very hard, because when you follow a firefighter units, every fire is different. Every place is different. One day it could be a restaurant fire. The other day it could be an underground fire. So the robot doesn't have the capacity to feel the things like a firefighter can feel the things on the battle. And this fact need to be on the brain of the operator, and the robot need to be here just for supporting. So on our feeling, we feel, and it's our DNA, that the main mission, the capacity to feel how I can manage my mission, need to build for and to keep for the firefighters, and the robot will be just the tools, maybe an intelligent tools, yes, but to manage simple missions.
No, definitely. And it's funny you say that. Actually, it reminds me of I've got a Roomba. The small little hoovers that map out your room and will just automatically go on each morning. And so I have 3 dogs, so a lot of pet hair. But anytime we decide to move around the living room, and even if it's just as simple as moving a side table, a quarter inch to the left, the poor Roomba's just, kind of driving straight into the side of the table, because he can't comprehend, he can't compute, that the layout of the room has changed, the blueprint of the room has changed. And like you said, every fire is different, and that blueprint for each building, that algorithm for each building is different. You're very much right. To have an operator, is the most important thing. So you're right in that respect, and it's nice to see that AI isn't a threat in this type of environment. We're looking at AI in lots of other types of environment, and it's we need to work within the guardrails. But actually, in terms of this, you're very much unlikely going to have an autonomous robot being able to climb over rubble and up and down different ledges and steps. So no, it's fascinating to hear kind of what is already happening, and that there is still a lot of innovation to come. But it's all exciting innovation. There aren't kind of big concerns there. I think that's all we have time for, but thank you so much for taking the time to talk to me.
Thank you very much. Thank you very much.
I really appreciate your time. And if anybody has any further questions, they can reach out to Cyril directly on the platform. Thank you.